Hey guys, this video is for Calculus BC and this comes from 7.4. It is called arc length. So arc length is really just the distance on a curve, okay? Before I explain to you this portion, which is how we come about the formula, I want to take a minute and just show you what's expected on the AP test is to have this formula memorized. This is one of the easiest questions to get. All you have to do is confirm that the function is smooth, meaning that it's continuous and it has no cusps or vertical tangents, okay? And then visually, if they tell you to find the arc length from 2 to 7, you're really just finding the length of this curve, all right, from those two numbers. And then the formula is the definite integral from a to b of the square root of 1 plus the function's derivative squared, okay? So again, have that memorized and just plug the information in. It is pretty simple. Now I'm going to take a few minutes on this video to explain to you how that formula comes about, and then I'll show you some examples, okay? So to start off with, if we're talking about the distance on a curve, we do start with the distance formula, okay? Now, if we want to rewrite things in terms of x, we know that from MVT, slope is equal to derivative. So I can isolate that y minus y1 by multiplying this denominator over to the other side. So now I'll replace this entire y minus y1 with this f prime times x minus x1, okay? And plug it in there and include that squared. All right, now I know that if x minus x1 is really just my change in x, my delta x, I'm going to change these two to say delta x, okay? We're still leaving those squares there. My next step is going to be to factor out these delta x squared. So remember that square belongs to the f prime and to the delta x. So I factor that out, right? Both of them. If I divide out a delta x squared here, I end up with 1 plus, and then again, that squared belongs to the f prime, and then close that parentheses times what I factored out. Now, remember that radicals can be split amongst multiplication, but not amongst addition. So I can split this up and say the square root of delta x squared, those cancel out, and this can just be written outside of the radical. All right, and now think of Riemann sums. That distance is just finding us a little distance and a little distance and a little distance, but that is the distance for a straight line. So Riemann sums had us add up a bunch of different areas under a curve. Here we're going to add up a bunch of different distances. So we write the limit as n approaches infinity of the sum of all of those little distances from a to b. And then like in Riemann sum, we replace the notation from the summation sign to the definite integral, okay? So that's how we come up with this formula down here. The definite integral from a to b of the square root of 1 plus f prime squared, okay? Always remember to check that it is smooth, that it's continuous, no cusp, and no vertical tangents, and then plug it into the formula. Let's take a look at this first example. It says, what is the length of the curve? There it's telling me what to do, of sine of x from 0 to 2 pi. So if we plug that into the formula, I'm doing the definite integral, right? So the length of the curve is going to be the definite integral from 0 to 2 pi of the square root of 1 plus the derivative of sine squared. So I'll say derivative of sine is cosine squared dx, okay? Now, at this point, I'm going to allow you to use your calculators. Now, the way we plug that in our calculator is we need to click alpha, window, and then number 4 says an integral. When you plug that in, it gives you this notation right here. See, this is if you have the TI-84 Plus, okay? This is my favorite calculator. It gives you these little empty boxes for you to just plug in what you need. So obviously I just put that there for show, but you're going to plug in the 0 on the bottom and the 2 pi on the top. Then in those parentheses, you're going to plug in the function, and then it leaves a little space after the d. You just need to put an x to let them know that you are working in terms of x. You press enter, and it gives you that your answer is 7.6403, okay? So because I'm rounding, I'm putting that approximation symbol, and we have 7.6403, and that is our answer. One of the easiest lessons you'll learn in BC. Let's take a look at the next one. Okay, what is the length of this function from 0 to pi over 4? So I'm going to write, if y is ln of secant of x, I'm going to take a minute and solve the derivative first so I can plug that straight in. Y prime is the derivative of secant, which is secant tangent, over what's in the inside, which is secant. So u prime over u. Notice these secants cancel, and I'm just left with tangent of x. Okay, so if my formula says that the length is equal to the definite integral from a to b of the square root of 1 plus the derivative, right, which we found was tangent, squared, now I can say tangent squared. Okay, so again, that formula is square root of 1 plus the derivative squared. I took a moment, I found the derivative, and then I plugged it in. This is an example of a question that would be on a non-calculator section of the AP test. And I'm bringing this up because they love to do this to you. They love to make you recall your Pythagorean identities, okay? So if you catch that the inside of this function is 1 plus tangent squared, and that Pythagorean identity equals secant squared, then you should have no problem finishing this off, right? So square root of 1 plus tangent squared is secant squared of x. Now a square root and a squared cancel. So I'm really doing the definite integral from 0 to pi over 4 of secant. Now I know the antiderivative of secant is ln of secant plus tangent, and then I'm going to do from 0 to pi over 4, okay? When I plug that in for my f of b minus f of a, I'm going to say ln of secant of pi over 4 plus tangent of pi over 4 minus my function at a, ln absolute value of secant at 0 plus tangent, forgot my absolute value here, at 0. Oh, sorry, I'm messing up here a little bit on my notation here. All right, sorry about that. It's tangent of 0. So the absolute value should have gone just at the ends. It's ln of absolute value of all of this. So this one should be taken off as well. And then ln absolute value of all of this, okay? Now, on the AP test, I've told you that you can go to f of b minus f of a, but if there is any trig left over, you do have to complete that portion. So I have ln of secant of pi over 4 is radical 2 plus tangent of pi over 4 is 1 minus secant of 0 and tangent of 0. I have an issue here because tangent of 0, remember at 0, let's put a little side note here. At 0, my ordered pair is 1, 0, okay? So if secant is the flip-flop of cosine and I flip 1, 1 over 1 is still 1. So secant of 0 is 1 plus tangent of 0 is the sine divided by the cosine. 0 divided by 1 is 0, okay? So now here I have ln absolute value of radical 2 plus 1. Technically don't need those absolute values anymore, guys, because radical 2 plus 1 is positive. And then I have minus ln of 1. And again, 1 is positive, so I don't really need those absolute value bars. But ln of 1, if we remember our graph, guys, we have this memorized that ln of 1 hits the intersect, so the x-intercept right here. So ln of 1 is 0. So this is like saying minus 0. So this cancels, and my final answer is just ln of absolute value of radical 2 plus 1. Okay? Now, for this question, if I want you to remember, if you see something in the non-calculator section, assume that there is something I can use. So if I stare at this in a non-calculator, don't freak out. Think to yourself, okay, what formulas do I know that I might be able to recognize, okay? All right, guys, let's take a look at this last question. So this one may seem like one that throws you off because this question is in terms of y. But I want to encourage you, it can be solved the exact same way. And again, this is one that would be on the non-calculator section. So if the formula makes me do the derivative of the function, I'm going to take a minute and solve that. If this is x, the derivative, so x prime, I would multiply that exponent to the front, 3 over 2, rewrite the inside, and then subtract 1 from here. If I subtract 1 from here, I'm subtracting 2 over 2, so I get half, and then times the derivative of the inside would just be 1. Okay, this is in terms of y, so I don't have to do implicit here. So these cancel, and I'm just left with y minus 1 to the 1/2. Okay, so now arc length is a definite integral from a to b from 1 to 4 of the square root of 1 plus the derivative, which I just solved. So if my derivative is y minus 1 to the 1/2, it's the derivative squared in the equation, which is really nice because this square and this 1/2 is going to cancel. So what I'm really working with is 1 plus y minus 1, which even better, the positive 1 and the negative 1 are going to cancel out. And I'm really just working with the square root of y. And look at me. I hope you caught a mistake that I was making. Very important on not necessarily the multiple choice because they're not checking your work, but on an FRQ, this is in terms of y. So that means that this needs to say dy. All right, just a technicality, didn't mess this up too much. So now if I'm going to do this integral, I'm going to change that to y to the 1/2 so I can do power rule. Okay, power rule says that I'm going to add 1 to that exponent, so I'm going to end up with y raised to 3 over 2, divide by my new exponent, so I'm going to have a 2 over 3, and I'm going to do this from 1 to 4. Okay, now if I plug in my 4, I'm going to leave my 2 over 3 on the outside and say f of b minus f of a. Okay, remember that when you have a fractional exponent, the base is the root and the exponent, the numerator is the exponent. So I'm going to do the square root of 4, which is 2, and then 2 cubed would be 8. So 2 over 3 times 8 minus 1 raised to anything is just 1. So I'm really here doing 2 over 3 times 7. 7 times 2 over 3 is going to give me a 14 over 3. And that is my final answer. Okay?